Now let's talk about use properties of inequality. We're going to introduce 4 properties solving inequality. One is called a non-negative property. For any real number a squared will be always a non-negative number. So we use inequality to represent that. It will be a squared greater than or equal to 0. Okay, any real number. Okay, we're not talking about a complex number here. Any real number, 1 raised to second power, it always non-negative. And then represent using inequality is greater than or equal to 0. So that's why this property is called a non-negative property. The second property of inequality is called an addition principle. It's very similar as addition property of equation. All right. So it states as if an inequality A less than B is a true statement, then both sides of inequality, adding or subtracting same number or expression, and then the new inequality will still remain the same symbol. If original is less than, and after adding same number or expression, still going to be less than. If original is greater than, and then after add both the same number or expression, and then the greater than still is still a true statement. All right, so this is called the addition property of inequality. So how we understand this? Let's look at a number line. Okay, see whether that help you, understand addition property of inequality or not. So let's say A, B, they are real numbers. Okay, so we can find it on the number line, and then point A is on the left-hand side of point B. So we say A less than B, right? And then we assume C is another positive number. Okay, so if A add a C, that means from point A, we need to shift it to the right-hand side C units, right? So now this point represents A plus C. And then the B, we also shift it on the right-hand side, the same amount of unit, okay, to the right-hand side. So that's why we say this point and this point, they still have relative same location, right? Just horizontally shifting from this position to the new position. But the relative position still remain the same. Okay, so you can consider adding a positive number. You can consider as the horizontal shift to the right-hand side. What if you subtract a positive number? And then very similar, you can consider this is A and B originally located this here. And then we shifting to the left-hand side, same unit, okay, same distance. So this is the new, okay, A plus C, and this is new B plus C. So A and C relative locations still remain the same, just shift it to the left-hand side. Okay, that's how we, understand additional property of inequality. The third property we're going to introduce is called a multiplication property for inequality. So we assume A, B, C, they're all real numbers. So multiplication property for inequality is a little bit different than multiplication property for equation. Okay, so where is different? So let's quickly review what about the equation. If we say A equals B, right? the equation case. Later, I'm going to talk about the inequality case. So I just try to let you distinguish the differences first so you won't make mistakes. If original statement A equals B is true, and then both sides multiply by any number or expression, and then the new expression still equivalent, right? That's what a multiplication property for equality means. But for inequality, because this inequality symbol has the direction, okay? So when you multiply this number is a positive or it's a negative, it's really make different, okay? If both sides of inequality multiply by the same positive number, okay? If C is a positive number, and then AC still less than BC. All right, this is this two statement. A less than B if C is a positive number and then both sides of inequality multiply by positive number and then AC still less than BC. And then that applied the same to the greater than case. But what if C is not a positive number? Okay, if C is a negative number, C is a negative number, and then both sides of inequality multiply by negative number, AC, BC, will still AC less than BC? The answer is no. You need to flip the direction of inequality symbol, okay, when you multiply both sides of inequality by a negative number. Okay, you see here original is less than. After multiply both sides by negative number, you need to flip the symbol to the greater than. And then same applies if original is A greater than B, and after multiply by a negative number, and then you need to flip to the less than. Okay, that's the only difference between multiplication property for inequality, compared to multiplication property for equation. All right, the last property is called a reciprocal property for inequality. It's stated as, if A is a positive number, then the reciprocal of A will still be positive. Okay, so what that really means? That means reciprocal, which is numerator denominator flipped. Okay, flip numerator denominator doesn't change the sign of this number. Okay, think about, does that make sense to you? For example, 5. 5 is the same as 5 over 1. If you flip numerator denominator, you get 1/5. So even though the number may getting smaller, but the sign doesn't change. If 5 original is a positive, after flip numerator denominator, the sign for this number is still going to be positive. All right, the value of the number changes, but the sign of this number doesn't change. That's what a reciprocal property really means. Okay. Same for the less than case. If originally A is a negative number, and then when numerator denominator switched, okay, we call it reciprocal, and then 1 over A still be a negative number, like a 1/5. After you flip numerator denominator, that will be negative 1/5, right? Negative 5 over 1, and then flip numerator denominator, that will be negative 1/5. So reciprocal property, I called it same sign property. Okay, just kind of easy for me to remember. So, up to you. If you can remember the, key for the reciprocal property, you can just memorize reciprocal property. If it doesn't make sense to you, you can just memorize it as same sign property. All right. So now let's try some example. How can we use those 4 properties for inequality to solve inequality? Okay, we have non-negative property, addition property, multiplication property, and reciprocal property. Okay, 4 properties here. So just like for solving linear equation, we would like to summarize all the procedures that leaves inequality symbol unchanged. So 3 procedures leave inequality symbol unchanged. 1, simplify. Okay, this is easy to understand. Simplify both sides, which is including combine like terms, eliminated parentheses. That doesn't change inequality symbol. Adding, subtracting same number or expression of inequality, symbol remain the same. Okay, multiply or divide both sides of inequality by the same positive number, and then symbol remain the same direction. Okay, so if you remember these 3, symbol will remain the same direction, and other than these 3, you need to flip the sign. Okay, flip the symbol. So what are the case we need to reverse the direction of inequality symbol? 1 is when you interchange the sides. Okay, 3 less than x. If you want to write x on the left-hand side, you need to write x greater than 3. Okay, that's different than equation, right? We say 3 equals x, we can write as x equal to 3. They are equivalent. But for inequality, because inequality symbol has the openings, okay, opening always need to face the same thing. So you see 3 less than x, right? The opening part facing x. So after you switch x to the left-hand side, opening part should also facing x. Does that make sense to you? So if you can remember this way, that will be fine, okay? And a second situation, you need to flip the direction of inequality symbol is when both sides of inequality you multiply or divide by a negative number or expression. Okay, for example, negative 2x greater than 6, we both sides divided by negative 2 to clear coefficient of x term, and then negative 2 negative cancel, left hand side is x, 6 divided by negative 2 equals negative 3. So we simplify both sides of inequality first, and then we decide the symbol need to stay the same or need to flip the direction. Okay, so since we both sides of inequality divided by a negative number, we do need to switch the direction of inequality symbol. Okay, so answer should be x less than negative 3. All right, let's try another example. Solving inequality 4x plus 7 greater than or equals 2x minus 3. So similar as solving equation, we need to let variable term on one side and then constant term on the other side, right? So let's subtract 2x on both sides. And minus 7 on both sides, so that all the variable term move to the left-hand side, constant term move to the right-hand side. Okay, so this cancel, what we have? 4x minus 2x, left-hand side we have positive 2x, and then right-hand side, negative 3 minus 7, we got a negative 10. So we simplify both sides of inequality first, and then determine the symbol should remain the same or we need to flip the sign. So we just adding or subtracting both sides of inequality, right? Doesn't matter positive, negative, addition property for inequality, so symbol should remain the same. Okay, so still keep greater than or equals to. Okay, and then after we solve inequality, it asks us to graph the solution set. Okay, oh, we haven't finished yet, sorry. And then in order to clear coefficient, we have to both sides divided by 2, right? Simplify, left-hand side is x, right-hand side is negative 5. So now the symbol, should we stay the same or flip the direction? We divide it by positive number, right? So symbol should stay the same. And then graph on the number line, negative 6, negative 5, negative equal -3. All right, so first located the boundary, -5. It have a equal sign, so closed, right? And then greater than or equals -5. We need to shade it anything on right hand side of these square brackets and an arrow pointing to positive infinity. Okay, that's how we graph this inequality. X greater than or equals -5. So that's a better graph. Okay, my hand graph doesn't look too good, so look at a printed one.